So the Kuiper belt defines the outer border of the heliosphere. You understand?
So all of the planets in the outer solar system are Jovian?
Yes. All of the planets in the outer solar system are Jovian.
The ones in the air are
Terrestrial.
terrestrial.
Exactly. So you have terrestrial planets made of rock and metal. Then you have the asteroid belt made of rock and metal. Then you have Jovian planets made of gaseous nature. And then you have the Kuiper belt, which is made of ices. The Kuiper belt, and this is important because that's on the quiz. The Kuiper belt is made of ices, like ammonia.
Ammonia is ice?
Ices are, peace, King.
Peace.
Ices are
Frozen liquid?
frozen liquid, exactly. And so ammonia frozen is a particular kind of ice. So there's ices like ammonia that are found in the Kuiper belt, which is on the outer skirt. So the Kuiper belt defines the outer border of the heliosphere, which is the outer border of the solar system. So it goes like this. If y'all can see this illustration, okay, you have the sun. This is from, for lack of a better term, an aerial view. You have the sun, then you have the four smaller planets, the terrestrial planets. Then you have the asteroid belt. Okay?
It goes all the way around the sun?
The asteroid belt. Yeah, it goes all the way around the sun. It models after the ecliptic plane. And then you have the gas giants. And this is probably to scale. This is probably really to scale right here, as far as the difference, how big those gas giants are versus like our Earth. Actually, it would be more like,
Wow, it's huge.
But Jupiter's not bigger than the sun.
yeah, that'll be something for you to look up. That'll be fun for you too. But they're actually more like that. They're way bigger. That's why they're called gas giants.
Are they bigger than the sun?
That's something for you to look up.
It's what it appears from the ground. So,
That's something for you to look up. Okay. And I'm telling you, the first video, if you go on YouTube to gas giants, the first video you see will answer that question. The first line, he's gonna answer your question with the first line. I guarantee you.
Crazy.
And that's what I want them to experience. You know what I mean? Not from me, but like, you know. So then outside is the Kuiper belt. See?
Sounds a whole lot like
The Kuiper belt, okay? Now, this also is the outer edge of the solar wind area inside here that's called what?
Hold on, say that one more time.
This is the outer border. The Kuiper belt is also the outer border. It defines the border for the solar wind. Huh?
The heliosphere.
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 For the heliosphere. The Kuiper belt defines the border for the heliosphere. Now, if you think about that, that's why they refer to it as solar wind. Even though it's made up of different gases and magnetic particles, they refer to it as solar wind because it kind of acts just like the wind. Imagine if this was wind spinning around the sun. The asteroid belt will be caught up in its wind. See, and it'll be stuck where it is. And then the Kuiper belt will be caught up in its wind and it will be stuck where it is. Well, if the wind stops blowing and it loses its magnetic force around here, all that stuff that's stuck right there is going to be defined as the Kuiper belt. See? See what I'm saying?
The wind part kind of confuses me.
The wind is spinning this stuff and it's keeping it close to the sun. The same way,
It's
like
gravity. You're
if you
saying
had,
it's making a gravity go towards the sun, the wind.
yeah, if you had like a string with a ball on it, and you just kind of lightly spin around, you're not creating too much wind, it's just gonna hang there. But if you spin really fast, the wind is gonna keep it in a certain position.
Okay, yeah.
Okay? Now, what will really bug you out is if you spun fast enough, you could actually cut the string and that ball would stay in that position because of the wind. the wind will continue to, you feel what I'm saying?
Yeah, and the string,
Even though the string is cut, the ball's gonna
stay
stay in that circular motion. Like if you ever see a vacuum where they got balls in a vacuum and then the balls come up and they stay in that particular spot because of the wind. So all of those iciest materials, all of those liquid materials that are found in the Kuiper belt are stuck to the sun, and the sun loses its gravitational pull right around the Kuiper belt. Okay?
Okay.
So that's what defines the Kuiper belt. Okay?
Okay.
All right. What do we have here? So we got heliosphere. Everybody understand what heliosphere is? Everybody understand what terrestrial planets are, what Jovian planets are, what the asteroid belt is, what the Kuiper belt is, and the general understanding of the solar system, correct?
Yes.
Okay. Now, satellites. Satellites, we're not going to get into satellites during this lesson. It's going to be a lesson 2, but I just want to introduce this idea. Satellites are actually just an object that orbits another object. Okay? So the satellites of particular planets in the field of astronomy, the satellites of particular planets are celestial bodies that surround those planets, that are stuck to those planets by its gravitational pull. The same way that our moon is a satellite to our planet. And many times satellites are referred to as moons of particular planets. Okay? Everybody get that? Make sense?
So it's just a body that circles another body?
That's it. In astronomy, it's a celestial body excuse me, that is attached to another celestial body by its gravitational pull. Much like the moon around our Earth. You understand? Makes sense?
Yeah.
All right.
So what is the asteroid belt again? The asteroid belt is what part of that picture?
The asteroid belt in this picture would be here. That would be the inner belt after the terrestrial planets. That would be the belt between Mars and Jupiter that's made of rock and metal objects.
Okay, because the rock and metal is those 4 planets, and it's still made of rock and metal. And
No, the rock and metal isn't those 4 planets. I'm glad that raises a good question though. The rock and metal is just celestial objects that just got caught up in the solar wind. And what we'll discuss a little further in cycle 2 of this particular lesson is, the formation of the solar, or maybe cycle 3, the formation of the solar system and how it came about. And you'll kind of understand more about how the asteroid belt came about. But basically, any solar system, let's just say, is orchestrated from collision. They say that our sun, or our Earth, came from collision. Yeah. So what happens is things collide, and then other things start spinning, and then other things get stuck to them. So when our solar system was being created, however you describe, and it's a lot of descriptions, but when our solar system was being created, collisions were taking place, and rocks spawned off from other rocks, and they just got caught in that belt.
And that belt is made of rock and metal.
Rock and metal, celestial objects.
And those 4 planets that's inside of that belt is basically surrounded by rock and metal.
Exactly. They're surrounded by this rock and metal in that asteroid belt.
So they're not rock and metal.
They are rock and metal objects, but there's also a bunch of smaller rock and metal objects spinning around them. All of them. More appropriately, spinning around the sun. Okay? Next is one of my favorite subjects. Yes? You had a question?
I was just going to ask, of these gaseous planets, is the core?
No, they're gaseous all the way through.
They don't have any core?
No solid surface. At least it's proposed at this point, in order for us to be considered an educational nonprofit.
What is gas? Gas?
I have to say that, yeah.
What is gas? Is gas like just like
Oxygen, helium?
But real quick, because that's a good question, and it is a